Let's now go over a couple application examples that involve exponentials. And to be honest with you, I don't know why I did so many examples. Pretty sure you're going to see these questions in my math lab, but yeah, we got 3 application problems here. So example 7 says, at the end of an advertising campaign, weekly sales of smartphones decline according to the equation y equals, which is in dollars, and X is the number of weeks after a campaign. So determine the sale at the end of the ad campaign, determine the sales 6 weeks after the end of the ad campaign, and does this model indicate that sales will eventually reach $0? So the easiest thing to do here is to graph this. If this is representing my weekly sales, we definitely want to start, especially if it wants to know what's happening at the end of this ad campaign. We definitely want to know what's happening after 0 weeks, right after this campaign ends. And then let's say 10 weeks after. I have no idea if 10's a good number or not, but let's go 10 weeks after. And because I have my X min and max, I will then hit zoom 0. So let's graph. And so we have 1200. Okay, so typing that in exactly the way it looks. And then I'm going to go window 0 to 10 and then zoom 0. So here is what my graph looks like. Okay. So if I need to determine the sales at the end of the ad campaign, we're talking about my X equaling 0. We're 0 weeks after our campaign. And what we mean by campaign is, a TV commercial, a radio advertisement, ad in the newspaper and a magazine, whatever this campaign is, right? So surely while this campaign was happening, it's increasing here. And now right here, my campaign has stopped. So it does make sense that these numbers are decreasing, right? You're not pushing that product in people's faces. So we have X equals 0. What I want to do is go trace 0, enter. And my Y is in dollars. So if I do trace 0, enter, we are at $12,000. So what is it at the end of 6 weeks? So now my X is 6. So we'll do trace 6, enter, or if you already did that one with me, you just need to really hit 6, enter. So 6, enter. Because we're talking about money, we're going to go to the nearest cent. So $8,603.73. Now, does this model indicate that the sales will eventually reach 0? You can do this one of 2 ways. One, we can expand this out. So let's go to 20 and I'll go zoom 0. Okay, and let's actually look at my window, my Y min. I want to change that to 0. Oh, and I did it 2. Let's try 20. Zoom 0. Thought that looked a little weird. Okay, so it's still leveling out. What is my window at again? Still my Y min is almost 4,000. Let's just go crazy. Let's go 100 weeks, almost 2 years after. So zoom 0. Okay, almost 2 years later, here's where we are. And so now what's my window at? Let's just change that y min to 0. And you can see here, when we go almost 2 years afterwards, it's still not actually reaching, right? If I go into my table, these values are going down, but they are never reaching 0, right? And why is that? Because all exponentials have a horizontal asymptote. And so at that horizontal asymptote, it is never going to reach 0. We can keep going and going. It will never reach 0 here, no matter how small these numbers get. So no, because there's a horizontal asymptote at y equals 0. Okay, example 8. Use the formula S equals P times 1 plus R to the T. So you can see, because of that exponent having a variable, that makes this an exponential. First, we need to graph the function that gives a future value of $30,000 invested at 8% interest compounded annually for T years between 10 and 12 years. So this tells me that my X min will be at 0. My X max will be at 12. It's really bad too. Then we will hit zoom 0. Now, what numbers are we plugging in here? My future value of $30,000 invested. So we don't know our future value, so that's my S. We are investing $30,000, so there's my P. 1 plus my R, which is this 0.8%. Or sorry, this 8%, which then will become 0.08. You gotta change that. And then to the T power. So let's put this into our calculator. Instead of T, we're going to put X, and we'll change our X min and max and hit zoom 0. So I have 30,000 in parentheses, 1 plus 0.08, and then to the X. And we'll go window 0 to 12 and zoom 0. So here is my graph. So if I put in $30,000, we can see I am gaining some interest here. And it wants to know, find the future value of $30,000 invested for 5 years at 8% annually. So this is all the exact same, but now they tell me how many years we are. So now my T equals 5. So we will do trace 5, enter. And then again, we're talking about money. So we will round to the nearest cent. So trace 5, enter. And we now have $44,079.84. Okay, I know this video is getting kind of long, but go ahead and just go to the next page in example 9. Says an antique table increases in value according to the function b of x, which is in, again, dollars, and x is the number of years after 1990. And that's a great year. I don't know if this is going to make you think I am old or young, but that's what year I was born. So that's a wonderful year. So part A wants to know, how much was the table worth in 1990? Part B wants to know, if the pattern indicated by the function remains valid, what will the value of the table be in 2005? And part C says, use a table or graph to estimate the year when the table would reach double its 1999 value. So because on part C, we're already gonna have to be using a table or a graph, we might as well use a table or a graph to find these two answers as well. So I'm gonna put this into my y equals Okay, and it doesn't really tell me years, but I know I need to go at least 15 years here. So I'm gonna go ahead and go a little bit beyond that. Let's just go to 20 and we'll hit zoom 0. Okay, so to get this graph here, what did we do again? We did x min of 0 and x max of 20. And you can pick any number. You can go 30, 40, 50, whatever you want. And then zoom 0. So if I want to know how much it was worth in 1990, and my x represents the years after 1990, we're talking about when x equals 0. So let's go trace 0, enter. We get 850, which should make sense because it's our number out front here. Okay, so it was originally worth $850. So if the pattern continues, what will the value of the table be in 2005? So this tells me that my x equals 15 because 2005 minus 1990 is 15. So now let's go trace 15, enter. And so again, if we've already hit trace, we don't need to hit it again. Just going to hit 15 and hit enter. And we are at $1,530.80. Okay, then last question wants us to use a table or a graph to estimate the year when the table would reach double its 1990 value. So it was $850 in 1990. If I am wanting to double of 850 would be 1,700, and I want to know when is that going to happen. So in my Y2, we will put 1,700. We will graph, and then we will find the intersection. I feel like we haven't done this in a while. Okay, so Y equals, keep your Y1 the way it is. Put in 1,700 and hit graph. Now we need to make sure we see an intersection. And luckily I do. If you don't see an intersection, you've got to change your window. So to find the intersection, we're going to go to calc. Go to number 5. And because we only have one intersection and just 2 lines, we're going to hit enter, enter, enter. And we are at x equals 17.67. Which rounds to about 18. So we would say in 2008.